Now let's look at one more question where we need to solve a similar triangle and the problems are a little bit more advanced. And in this particular problem, we need to figure out what this missing side length BD is in these triangles here. And what we can notice is that we have a triangle ABC that is within a bigger triangle, ADE, and we can prove that these two triangles are similar. Since notice they each have a right angle and they each share this angle A. And if two triangles share two sets of equal angles, then we can prove that they also share a third set of equal angles. Or in other words, that the two triangles are similar. So to prove that two triangles are similar, you just need to know that they have two sets of equal angles. And by extension, they would also have a third set. You can prove that, and we looked at that in the previous video. Now we want to write that triangle ABC is similar to triangle ADE, and remember that the order you write this matters. And from here we can set up proportionality relationships so that we can figure out what this missing side length x is. Since remember that in similar triangles, the side lengths are proportional, meaning that if we start at the smaller triangle, each of these side lengths are multiplied by the same number to get the bigger triangle. So if we can figure out what we multiply by to go from the smaller triangle to the bigger one, then we can figure out missing side lengths. Or we can set up equations of proportionality. Since if we look at the ratio of this side length ED compared to its corresponding side in the smaller triangle, this would be equal to the ratio of, let's say, this side length AD compared to the corresponding side in the smaller triangle AB. And with that information, let's set up an equation. We have that the ratio ED compared to CB, this is equal to the ratio of AD compared to AB. Since the proportionality constant is equal when we consider the ratio of any of the corresponding sides. And we could extend this one further. We can look at the ratio of the bigger hypotenuse, AE, compared to the smaller hypotenuse, AC. These are all equal to each other, but in reality, we just need to look at these two since we have information for these two, and we can solve for x. And just plugging in information, we have that ED is 3, CB is 1, and this is equal to AD, which notice is composed of AB plus BD. And we can write that as 2 plus x, since at this point we don't know what x is. And we're dividing this by AB, and AB is 2. And now we have an equation where we can solve for x. So to do that, let's cancel out the fractions. We can multiply both sides by 2, and since this is just division by 1, this is really just 3. And 2 times 3, that's 6. On the right-hand side, the 2's will cancel each other out, and we just get 2 plus x. Now to solve for x, let's subtract 2 on each side to find that x is equal to 4. And before we know for sure that this is the correct answer, we should test it. Since if we plug this in, we have 4 here, meaning that the total length of this bottom side, AD, is equal to 6. And when we look at the ratio of the bottom sides in each of these triangles, we take 6 and we divide it by 2. And notice that this is 3, which means going from this side AB in the smaller triangle to its corresponding side in the bigger triangle, AD, we do multiply 2 by 3 to get to 6. 3 is the proportionality constant. But you can see that's true when we look at CB and we compare it to its corresponding side in the bigger triangle. We again are multiplying by 3. So in both cases, that proportionality constant was the same number, which helps us feel confident that this is in fact the correct answer.